Hello, my dear students. Welcome to my YouTube channel, that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today's topic for the lecture is the different types of hybridizations and their structures. In the previous lecture, we have done about a deep introduction about what is hybridization, and today we are going to do its different types along with their structures. So, in the upcoming lectures, we will be discussing all the types of hybridization, but one by one. Today, we are going to just doing the general introduction about the different types of hybridizations. So, the very first type of hybridization is sp hybridization. The very first type of hybridization is sp. Now, the covalent compound having the general formula of AB2 will undergo this type of hybridization. Let me take an example of AB2 to be beryllium chloride, BeCl2. So now here the central atom is A and the side atoms are B. So the structure of the AB2 undergoing sp hybridization will be, that's our central atom A forming covalent bond with B, another covalent bond with another B, with an angle of 180 degrees, with an angle of 180 degrees, and this structure is known as linear. That's the linear structure. So that's our first type of hybridization, that's sp. Now let's talk about the second type of hybridization. The second type of hybridization is sp2. So the general formula of the covalent compound undergoing sp2 hybridization is AB3. Here central atom is A and side atoms are B. Let me take an example of AB3. That's boron trichloride. It's BCl3. So what will be the structure of AB3? That's our central atom A. That's B over here, and third B over here. So here the bond angle is 120 degrees, and this structure is known as trigonal planar structure. Now let's talk about the third type of hybridization. The third type of hybridization is sp3. The general formula of the covalent compound undergoing sp3 hybridization is AB4. Now let me take an example of AB4. That's methane molecule, that's CH4. So now let's make the structure of CH4 or AB4. It's in 3D. Central atom A over here, that's B over here, and B over here. These two are the covalent bonds which are on the screen. This is the dash and B over here. This is called dash. I'm making it in 3 dimension. That means this, wedge. This is called wedge. So that means this wedge bond is coming out of the screen, and this is called the dash bond, which is protruding inside the screen. So it's in 3 dimensions and I'm marking it. This is called wedge, which is coming out of the screen. This is called dash, which is going inside the screen, and another two bonds are on the screen. Here the bond angle is 109 degrees and 28 minutes, and this geometry is called tetrahedral geometry. This is called tetrahedral structure or geometry. Here all the angles are 109 degrees and 28 minutes. Please do try to understand this structure, that's tetrahedral structure, in 3 dimensions. Now let's talk about the hybridization sp3 but with one lone pair. So now I'm taking my fourth to be again sp3 but with one lone pair. So the general formula of the covalent compound showing sp3 hybridization with one lone pair is ab3l. Let's take an example of ab3l to be nh3. Now the A central atom is over here. I'm making this wedge. Wedge is a bond which is coming out of the screen. B over here. The dash, second B over here, and this bond is going in the screen. The third one, bond with B, this is on the screen, and we are having one lone pair which is present at this position. That's the lone pair, that is 2 electrons, or the lone pair obviously comprised of 2 electrons. So while naming this structure we have to ignore the lone pair. So this structure will be in the shape of pyramid. So this structure is also called pyramidal, but not the tetrahedral. During naming the structure we have to ignore the lone pair. Now this structure will resemble the pyramid, so its name is pyramidal structure. Now let's talk about again sp3 but with 2 lone pairs. Now I am taking fifth one to be again sp3 but with 2 lone pairs of electron, that's ab2 l2. I am taking an example to be h2o. Now A is present over here. That's B. That's B on the wedge. And one lone pair over here and one lone pair over here. Here we again ignore the lone pair while naming the structure, and this structure will be called as bent shape. Bent shape, or we can also call it V shape. Now in case of lone pair I have not mentioned the bond angles. We will talk about the bond angles in the theory called Vesper theory. The valence shell electron pair repulsion theory deals with the bond angles and the repulsions between the lone pair, lone pair, lone pair, bond pair and the bond pair, bond pair. The bond angles actually varies in these structures according to the electronegativities of A and the B, which we will be discussing in the Vesper theory. So now let's talk about the another type of hybridization, and I'm taking it to be DSP2. The DSP2 hybridization is shown by the covalent compounds having the journal formula of AB4, but DSP2 hybridization is shown by the compounds having coordinate bond in between them. For example, we are having Ni CN4 2 negative. We will discuss about this hybridization in the chapter called coordinate compounds. Here let's draw a structure. A over here, that's B over here, B over here, B over here, and the another B over here. Now I'm just imaginarily linking the B's with each other. There is not any chemical bond, but it's just an imaginary linkage to make you understand this structure in 3 dimensions. So it is just a square plate in 2 dimensions. So here all the bond angles are of 90 degree, and this structure is called square planar. Now let's talk about the another hybridization, and that's the 7th one, and its name is sp3d. Now the covalent compounds having the general formula of AB5 will show this type of hybridization. Let me take an example. Its example is PCl5. Now let's draw a structure. The A is over here, that's first B, that's second B, and that's the third B. Now we are just imaginarily linking the B's just to make you understand this structure in 3 dimensions. So first of all, this is the equatorial plate. So the bonds in the equatorial plate or the triangular plate are called equatorial bond. Equatorial bonds. Now we are left with two B's because they be AB5. So the another B will be over here. That's B, and that's our fifth B. I hope you are getting the structure in 3 dimensions. The two B's shown in yellow color, the bond formed by them are called axial bonds. These are called axial bonds. Now, the bond angle of axial bond with this equatorial plate is of 90 degrees, and the bond between the B's present on the equatorial plate is 120 degrees. Now this structure is called triangular trigonal bipyramidal. This structure is called trigonal bipyramidal. Now let's talk about again sp3d but with one lone pair. Now I'm talking about the eighth one. Again sp3d but with one lone pair. So it will be, general formula will be ab4l. I'm taking its example to be sf4. Now let's talk about the structure. Now A is positioned over here, the B is present over here and over here. In case of sp3d hybridization, if lone pair is there, then that lone pair will always hold the equatorial position. So we are having the lone pair on one of the equatorial position. So I'm just imaginarily linking this lone pair with B's just to make you understand the structure in 3 dimensions. Now we are left with B. Now I'm marking the B, first B to be over here and the another B to be here. Now this structure is named as seesaw structure. When sp3d hybridization is having the lone pair, then that lone pair will always hold the equatorial position. Now let's talk about again sp3d but with two lone pairs. Now I'm talking about at the ninth one. Again sp3d but with two lone pairs, then it will be ab3l2. Its example is brf3. So I'm again drawing the structure. The A is present over here, B is present over here. Now we are having two lone pairs, then that two lone pairs will hold the two equatorial positions, lone pair and the lone pair. So these two lone pairs are holding the equatorial position. Let me link these. Now I'm going to draw the another two B's. The first B over here and the second B over here. I hope you are getting this diagram in 3 dimensions. Now this structure is termed as T-shaped structure. Now again I'm not mentioning the angles. We will be discussing the angles in the VSEPR theory, the valence shell electron pair repulsion theory. Now let's talk about again sp3d but with 3 lone pairs. Now the 10th one is sp3d but with 3 lone pairs. I'm taking it example to be like a general formula to be ab2l3. Now the example for ab2l3 is I3 negative. Now let's draw its structure. The A is over here. Now we are having 3 lone pairs. Then that 3 lone pairs will hold the position on the equatorial plate. So these are the 3 lone pair on the equatorial position. Now I'm just linking them. Now the two B's are there, so it's B and B. Now in this case we can talk about the bond angle, and we can easily get that the bond angle is 180 degrees over here. So 180 degree bond angle is in the linear geometry. So this structure is called linear structure in case of sp3d having 3 lone pairs. Now let's talk about next type of hybridization, that's sp3d2. Now the 11th one is sp3d2. The sp3d2, the general formula of the compound showing sp3d2 is ab6, and I'm taking the example of sf6. Now let's draw structure. The A is over here, B is here, 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 and here. Now I'm just imaginarily linkage the B's over here. Now these all 4 B's are on the square plate. We are left with 2 B's, and that 2 B's will be on the axial position. So that's the first B on the axial position or the axial bond. That's the second B over the second axial position. Now let's talk about the angle. First of all, the bond angle is, this one is 90 degree. Just try to imagine it in 3 dimensions, and rest all the bond angles are 90 degree. Now the name of this structure is octahedral structure. Now let's talk about sp3d2 but with 1 lone pair. Now I'm coming on the 12th one. Again that's sp3d2 but with 1 lone pair. It's ab5l. The example for ab5l is XEO F4. So here in this case in sp3d2 the lone pair will hold the axial position, not the equatorial. So there, here's the A, that's B over here, B over here, B over here, and the B over here. Now we can just imaginarily link the B's just to imagine this structure in 3 dimensions. Now the fifth B is present over here, and a lone pair is holding the axial position in case of sp3d2 hybridization. So we have to just ignore the lone pair while naming the geometry. So this will be square pyramidal. This will be called as square pyramidal. Now let's talk about the next geometry, that's sp3d2 again but with 2 lone pairs. Now we are coming on 13th. The hybridization is sp3d2 with the general formula to be ab4l2. and we are taking the example of this to be XCF4. Now here A is present over here, that's B over here, second B over here, third B over here, fourth B over here. Now we are just imaginarily linking the 4 B's to each other. So that's the square plate. Now we are having two lone pairs. That two lone pairs will hold the axial positions. The first one over here and the second lone pair over here. So these two are the axial positions. So now while naming this geometry, we have to ignore the lone pairs. So we are just left with the only square plate. So this structure is called square planar. Now let's talk about the next hybridization, that's sp3d3. Now we are talking about the next hybridization, 14th, that's sp3d3. The general formula of the covalent compound showing this hybridization will be AB7, and I am taking the example of IF7. Now for AB7, firstly we have to make a pentagonal plate. That's A over here, the first B, the second B, the third B, the fourth B, and the fifth B. Now we have to just imaginary link these B's with each other. Now this is the pentagonal plate in the 2 dimensions, and all are the at the equatorial positions. Now we are left with 2 B's, and that will occupy the axial positions. That's B over here and B over here. So this type of geometry is called pentagonal bipyramidal. The geometry is pentagonal bipyramidal. Let me talk about the angles over here. Just a second. It's all angles over here are, first of all, on the equatorial plate, that's 72 degrees. All are 72 degrees, and the bond formed between the axial position and the equatorial plate is 90 degrees. So these are the different types of hybridizations that we are going to do in the next lectures. In the next lecture, I am going to discuss all the hybridization one by one with a detailed example in the upcoming or the incoming lectures. Stay tuned to understand all types of hybridizations one by one in a very great detail and depth. So that's all for today. I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please do like, subscribe and share this channel to maximum number of students. Stay blessed.